Hello. For this problem, well, there's two of them. You want to use the hypothesis testing for proportions, because these are proportions. And we plug in here where it's gray. So if we see, given proportion 0.3714 and n, which is our sample size is 35 for the high income group. Test the claim that the proportion of children in the high income group that drew the nickel too large is smaller than 50%. So we're testing less than 50. Indicate the correct alternative hypothesis. Well, smaller than 50 would be less than 0.5. Well, there's two of them. There's this one and this one. But this is a proportion. Right here it says proportion, so it's P. If it said average, then it would be mu. So it's P. To find the test statistic and the p-value, we'll plug our values in here. Level of significance, it's at 0.1. Sample size, 35. A number of yeses in the sample. It's at 0.3714. So we need to find that value. Take 35 times 0.3714 and we get 13. And population proportion, that's from your hypothesis, so it's 0.5. Test statistic, right here, negative 1.52, right there, same. And then the p-value, this is a left tail because it's less than. So for a left tail, 0.0641. If the p-value is less than alpha, remember alpha was 0.1. Further, where's alpha? Oh, there's alpha at the top, 0.1. And our p-value was 0.06, so this is p-value is less than. If the p-value is less than alpha, reject. And so we rejected the null hypothesis, which means the sample data supports the claim. Because we're rejecting the null, that means we're accepting the alternative, which it was less than. This other problem, there we go. In a certain school district, it is observed that 30% of the students in the elementary school were classified as the only child, no siblings. However, in a special program for talented and gifted children, 108 out of 295 students are only children. The school district administrator wants to know if the proportion of only children in the specific program is significantly different than the proportion of the school. To test, alpha is 0.02 level of significance. So 0.02, put it in the gray part. Our sample size was 295. The amount that for the siblings was 108, and the proportion was 0.3. We want to test why did they put it the school district one? Significantly different. So we're not testing more than or less than, we're testing significantly different, and that's why it makes a two-tail, because it could be greater than or less than It's just that it doesn't equal it. And when it's two-tailed, then your alternative has to be not equal to. So it would be this one here, the not equal to. To find the values, they're over here. I plugged in my numbers, the test statistic. 2.477. The p-value we're testing not equal to, so that's a two-tail, so it's this one. And then the p-value 0.01, alpha was 0.02. So the p-value is less than, which means we reject the null hypothesis. We accept that it's different.